All right, so in this video, I'm going to be looking at how to perform some basic functions in MATLAB. Now, these set of tutorials I originally created for my Calc 2, Calc 3, linear algebra and differential equation students. So those are the kind of applications that we're going to be focusing on. I will warn people who like to code in MATLAB that I am using MATLAB in these examples as a glorified calculator. I make no apologies for that. Um, but the functionality of the commands is not impeded by that. And you can also always, if you want to write scripts that involve these functions, they work perfectly fine inside scripts. But I had a mixture of students when I developed this class, some that had used MATLAB before and some that hadn't. And I wanted to get everybody functioning and up to speed as quickly as possible to help them solve problems. And so this was the approach that I adopted rather than teach everybody everything there is to know about writing MATLAB code. Now, at some point in the future, I hope to add other topics such as statistics, numerical methods, modeling, data science, that sort of thing. But for right now, we're going to be focusing on applications for Calc 2, Calc 3, DiffyQ, and linear algebra. And so today we're going to begin with some applications for Calc 2. And hopefully you'll find this video or some of the other videos in this playlist useful. Now we're going to begin by declaring our variables. And we do that, again, from the command line by declaring whatever variables we're going to use with the sims function. Now, this basically just represents the symbols that we're going to use, and so now they're not available for other kinds of variables. We're going to declare a function, not like a program that we're writing, but just a mathematical function. You do have to, in MATLAB, explicitly do a multiplication for coefficients of your variables. It won't register otherwise. Now, if you just hit enter here on this line, then it will display the function that you just entered to the command line. However, if you want to suppress the output, you can simply put a semicolon after it, and then it will ingest that function into the memory, but it won't output to the command line. Now, there are several different ways to plot things in MATLAB. So one older plotting function is called EasyPlot, and it works really conveniently. You specify the function that we just defined that we want to graph, and then the window on which that you want to, the interval on which you want to plot it. And when you run that, then a window will pop up that displays the graph of the function. So for example, this is the graph that popped up. Now, if you put this EasyPlot function into a script, you actually get a warning that MATLAB would prefer that you use a function called fplot, which fortunately works with exactly the same syntax. Probably something that was created since I wrote my examples. And if I hit enter, then the figure will pop up, or it will overwrite the figure that you already have open. And so in this case, fplot actually also plots the vertical asymptote on the graph, which is very nice. So there are some newer features in this fplot function that you can use. I may switch back and forth between fplot and EasyPlot. I've been using EasyPlot a long time, but as you can see, fplot does have a little bit more in terms of its functionality. And so if you're a new user, that's probably the better function. And who knows, maybe I will make the transition myself. Now, if we continue, we now want to do the antiderivative of this function. We've seen what it looks like. What is the antiderivative? Well, we'll just use the int function. And I'm going to specify a function that I want to integrate, which in this case is just f. And then I have to specify the variable that I'm going to integrate with respect to. And if I hit enter, then it gives me the antiderivative right here. I can also integrate other kinds of functions, special functions, for instance, 1 over 1 minus the square root of x squared. And that gives me a sign. That means arc sign, so it's the inverse sine function. Now, you'll notice that in MATLAB, it does not give you the plus c. Obviously, if you're using this to check your answers on an integration problem, you would want to make sure that on paper you added the plus c. We can also do, for instance, students often forget functions like a to the x integrations, and it will give us the function without any difficulty. Now in MATLAB, log stands for natural log. So just kind of be aware of that is not log base 10. We can also integrate using substitution. So, oh, I forgot. That's my mistake. You can't use E. You have to use EXP and not a caret, but it's a function EXP. And now you get your exponential antiderivative according to substitution. We can also do very complicated functions with other kinds of substitutions. So sine of cosine of x times sine x. And notice that it nicely highlights the parentheses as you close them so that you know which parentheses you're closing. And so in this case, I got cosine of x. And I can also do definite integrals in addition to indefinite integrals. All I have to do is add the limits of integration that I want to use to my integration function. So this is integrating the cube root of x with the 1/3 power plus 1. And when I hit enter, then it gives me a numerical answer, in this case, 73/4. Now, one other application that we may be interested in early on in a Calc 2 class is finding the area between two curves. So let's enter two curves. So I'm going to use a new f function, x squared minus 4 times x plus 3. And I'm also going to enter a g function. G is equal to negative x squared plus 2 times x plus 3. And I'm going to plot these. So let's try fplot and see how that works. F, comma, and we're going to plot it on the interval -1 to 5. And so this is the plot. Now, if I want to add another graph to this plot and not overwrite it, then what I'm going to need to do is I'm going to need to add hold on. And now when I add additional graphs, it's going to graph on top of the existing graph. So on the same interval, I'm now going to also plot my g function. And so now my graph, I have both of them graphed here, and you can see they do have two intersections. We want to find the area between these. Now, when you are done adding functions to your graph, then turn that hold operation off so that the next graph will overwrite the entire thing and not just keep being added. So now we're going to find out where the intersections are. So we're going to use the solve function. Now by default, everything is solved for the functions equal to 0. And then, so this is f minus g equals 0. So where are they equal to each other? And then we're going to solve for the variable x in the expression. And it gives me 0 to 3. And so now I'm going to integrate. My g function was actually the one on top during that, in the middle of that interval. So g minus f, integrating x between 0 and 3. And it gives me the value of that area between the two curves.